Today we are going to discuss about AC circuits. Generally, circuits can be analyzed in AC as purely resistive, purely inductive, purely capacitive. Purely resistive, purely inductive and purely capacitive here means it has only resistance, it has only inductance and the circuit has only capacitance. Now considering the purely resistive circuit, here we consider a single resistance when supply is AC and AC instantaneous value is given by Vt, that is equals to Vm sin omega t. Then the current flowing in this circuit when supply is AC, that current will also be AC, which is given by Vt by R. Vt is the R instantaneous value, putting the instantaneous value Vr sin Vm sin omega t upon R. This component will remain constant and hence it represented as Im, and hence simplifying this function as current wave, then it will be It is equal to Im sin omega t. Then here Im is equal to Vm by R. Now considering the RMS value, knowing the value of maximum value, then RMS value will be equals to uh, RMS IRMS will be equals to Im upon root 2. We are knowing the voltage RMS value of voltage Vrms, then divide by R, then also IRMS can be calculated. Now in this circuit, because there is some voltage applied and current is flowing in the circuit, the power consumption will be P is equal to IT into my Vt. It we know Im sin omega t, Vt we know Vm sin omega t. Multiplying these two functions and further simplifying, then P will be equals to this function as a as a function of time. Now considering the cycle over the period 0 to pi, here we consider this is the waveform for voltage, this is the waveform for voltage, this is the waveform for current. Because V is equal to Vm sin omega t, I is equal to Im sin omega t, the phase lead or lag between the two is 0, and hence both the quantities are in same phase. They are having their magnitude may be different, but they are passing 0 at same time. Now the product of these two quantities, because both current and voltage both are positive, then power will be positive. Similarly, after this negative half cycle, both the current and voltage waves are negative. The negative and negative multiplied, then power will be again positive. Here we can say power varies from positive cycle in this way, whereas the in negative cycle it will be varying in this way. Though in AC supply the power is vary from minimum to maximum, if we are taking the average of this function from 0 to pi and then pi to 2 pi, because the average value between 0 to pi will be same when pi to 2 pi is taken. Here we consider power 0 to pi and taking the area under the curve. The area under the curve is given by this function P is equal to instantaneous value, integrating this function with respect to 0 to pi and area under the curve taking it as 1 oblique pi. Then it is 1 by pi 0 to pi, integrating this function with respect to d omega t, the resultant value will be Vrms into Irms. Because Vm into Im, the rest component will become 0 over the, this is to cos of 2 omega t, will component will be 0, then we will be having Vm into Im divided by 2. Vm by is dividing this 2 into 2 component, root 2 and root 2, then it will be Vrms into RMS. But now here it can also be observed that these two quantities, when they are having instantaneous function, taking along the reference, the quantity Vm can be represented as Vm V angle of theta is 0, because here plus minus is 0, then I can also be written as I angle of 0, angle of 0, 0, since both are having angle 0 and hence they are in phase with each other and taken along the reference axis, and that is why the current and voltage in purely resistive circuit in AC circuit are in same phase. Now considering the purely inductive circuit, instead of having a resistance over here, let we are having an inductor. In case of inductor, Now the supply is AC. When AC supply is applied across this inductor, there will be some rate of change of flux, and it will develop its own EMF. That EMF is taken as, let here it is E. Now the applied voltage is just opposite to this developed EMF. Here we can say it is in this case here it is considered as VL. The voltage developed across the inductor is already taken as VL. Now considering these two voltages, applied voltage is V, Vt, and voltage developed across the inductor is VL. Apply KVL in this loop, then it will be Vt minus VL is equal to 0, because these two are just opposite to each other and equal. Vt is equal to VL, and by the definition we know VL is equal to L di by dt, where I is the function of time, then it is it. V is equal to Vm sin omega t. Since we have taken angle from this is taken angle, it means this angle is 0. Now rearrange this equation for it. It will be equals to Vm by L, integrating the function sin of omega t dt with respect to time, and finding out the it on simplifying this function. This cos is resolved into sine of function, then it will be Vm omega L sine of omega t minus pi by 2. Though here the angle for voltage with respect to reference was 0, whereas in this case, in case of current, the angle is minus pi by 2. Now this quantity uh, is considered as constant. If we are comparing this equation with standard, in standard it will be equals to Im sine of omega t, if here it is angle, minus pi by 2. This is the standard form. Then we can say Im will equals to Vm divided by omega L, then Im is equal to Vm by omega L, and in this case omega L is nothing but is XL. XL is equal to omega L. Omega is 2 pi f L, and therefore since we are knowing the RMS value of the voltage is Vrms, and if we are taking RMS value of the current and voltage, then it will be Irms is equal to Vrms upon XL. Now omega L is equal to XL we have already considered. Now calculating the power in this circuit, P will be equals to instantaneous value of current into my instantaneous value of voltage. Instantaneous value of voltage is Vm sin omega t, whereas instantaneous value of current we have already find out, which is equals to Im sin omega t minus pi by 2. And it means, what does it mean pi by 2? It means current and voltage are having a phase difference of 90 pi by 2. Pi by 2 here is 90. Now if this is the waveform for voltage, current is waveform is minus pi by 2, it means it will start after pi by 2, and this is the angle pi by 2, here it is pi by 2, and the current will start from here, this is pi by 2, and extending this waveform in negative direction as well as here, then we can say the current and voltage, this angle is pi by 2. The current and voltage are lagging by an angle of pi by 2. If we are taking voltage as reference, because its angle is 0 along the reference, then current will be pi by 2 behind the voltage vector or voltage phasor V, that is pi by 2. Why it is taken as behind? Because sign is minus. If the sign was plus, then it would have taken in the upper direction. Now this is the phasor diagram. The electrical quantity here can be represented in mathematical form, in wave form, and in phasor form. Now further expanding the power in this case, at this instant this voltage is positive whereas current is negative. In this case, then the resultant power will be negative for this period. This is the waveform for power. Now at this instant both current and voltage are positive, and hence power will be positive. Then again at this instant current is positive whereas voltage is negative, then the resultant power will be negative, and hence the nature of power in case of purely inductive circuit, pulsating. And this pulsating nature means the power, instantaneous value of power can be positive and negative. However, if we are taking average of this cycle, the resultant average power in this inductive circuit from this observation we can say positive and negative cycle both are equal and hence cancel each other, and hence we can say the resultant power or average power for this purely inductive circuit is 0, and this can be proved mathematically. Here we are simplifying this function integrate from 0 to pi or 2 pi, taking the integration function 0 to 2 pi, then limit will be 1 by 2 pi. Then simplifying this function, here we have taken for 1 by pi because whatever the average value for, here it is taking the limit. Then simplifying this function, here the limit is taken as 0 to pi because whatever the value from the negative half cycle, first half cycle, then it will be same for the second half cycle. Then simplifying this function here, then resultant value will be given by this one. This trigonometrical function is simplified. Integrating this function from 0 to pi or 0 to 2 pi, then limit will become 2 pi. If it is taken 2 pi, then it will be 2 pi. The resultant value will be 0 over the complete cycle. Now, consider another classification of circuit is purely capacitive circuit. In purely capacitive circuit, again we consider there is a capacitor. The applied voltage is Vt, that is sinusoidal function or instantaneous value. Because of this AC, the current will be AC. The magnitude of AC current will be Im sin omega t plus minus theta. Since we know it is equal to C dV by dt and Vt function is known to us, which is equals to Vm sin omega t. Differentiating this function, it can be written as, it will be cos of omega t. This cos of omega t is converted into sine of function, then it will be omega c Vm sin of omega t plus pi by 2. Here again we can say this function is constant by comparing this with the standard, that is Im sin of omega t plus pi by 2. Then we can say this function is nothing but Im, and that is taken as Im is equal to omega c Vm, and further simplifying omega c, we know xc is equal to 1 by omega c, that is omega c is taken as 1 by xc, and then Im is equal to Vm upon xc. Similarly we can say Irms is equal to Vrms upon xc. Considering the waveform, let we consider, since the voltage, the angle for this function is 0 with respect to reference, and hence it is taken along the reference. This is reference. Now along this direction, this waveform is for voltage. This current will be plus pi by 2 because it is having a phase displacement of pi plus pi by 2. It means it starts before this voltage by an angle of pi by 2. This angle is pi by 2. After this reference point, this Vt will start. Now considering this both the quantities voltage and current, their phasor can also be represented. If V is taken along reference because its angle is 0, then current will be taken as pi by 2 leading the voltage V. This is pi by 2, and hence this is the phasor representation of the purely capacitive circuit. Now considering the power, again power will be the product of current and voltage. Considering instantaneous value of current, instantaneous value of voltage, instantaneous value of voltage Vm sin omega t, instantaneous value of current is Im sin omega t plus pi by 2, then the resultant value will be this one. On simplifying this trigonometrical function, putting the limit from 0 to pi or 0 to 2 pi, then it will be average value can be calculated for the cycle. Then the resultant value for this complete cycle is always 0, and hence we can say in case of inductor and capacitor, the power consumption in circuit is always 0. Though it was in inductive circuit, the power consumption was 0. In case of resistive circuit, the power consumption is Vr into my IR, Vrms into my Irms. The power in electrical circuit is always consumed in resistive circuit. Power is always consumed in R only. There is no power consumption in inductor and capacitor.